Welcome, detectives. My name is Jason Richards, Microsoft Technical Trainer and Data Detective. Data warehousing workloads benefit from the rich capabilities of the SQL engine over an open data format, enabling us to focus on data preparation, analysis, and reporting over a single copy of their data stored in their Microsoft OneLake. Together, we'll solve the mysteries of fabric warehouses, including what a fabric warehouse is, how to design one, creating objects, ingesting data, using semantic models from one, and security and monitoring aspects. That's a full list of mysteries to unpack, so let's start unpacking, detectives. Our first mystery is a fundamental question. What's the difference between a lakehouse and a warehouse? And when would I use one or the other? Wait, that's two questions. Anyway, Fabric's Lakehouse is a collection of files, folders, tables, and shortcuts that act like a database over a data lake. It's used by the Spark engine and SQL engine for big data processing and has features for ACID transactions when using the open source Delta formatted tables. Lakehouse is a great place to enrich and store data, but it's not the best place to serve data to business users. For that, you need a data warehouse. Fabric's data warehouse experience allows you to transition from the lake view of the lakehouse, which supports the data engineering and Apache Spark, to the SQL experiences that a traditional data warehouse would provide. The lakehouse gives you the ability to read tables and use the SQL Analytics endpoint, whereas the data warehouse enables you to manipulate the data. In the data warehouse experience, you'll model data using tables and views, run T-SQL to query data across the data warehouse and lakehouse, use T-SQL to perform data manipulation language, or DML operations, on data inside the data warehouse that always adheres to ACID transactions, and serve reporting layers like Power BI. Mystery solved. If your end goal is analytics reporting, then a warehouse is better suited than a lakehouse. Anything else about the warehouse experience? Glad you asked. Fabric's data warehouse is a relational data warehouse that supports the full transactional T-SQL capabilities you'd expect from an enterprise data warehouse. It's a fully managed, scalable, and highly available data warehouse that can be used to store and query data in the lakehouse. Using the data warehouse, you're fully in control of creating tables, loading, transforming, and querying data using either the Fabric portal or T-SQL commands. You can use SQL to query and analyze the data, or use Spark to process the data and create machine learning models. A huge feature of the warehouse is cross-database querying, which enables you to leverage multiple data sources quickly and seamlessly for fast insights and with zero data duplication. Data warehouses in Fabric facilitate collaboration between data engineers and data analysts, working together in the same experience. Data engineers build a relational layer on top of the data in the lakehouse, where analysts can use T-SQL and Power BI to explore the data. In the data warehouse experience in Fabric, you can build a relational layer on top of the physical data in the lakehouse and expose it to analysis and reporting tools. You can create your data warehouse directly in Fabric from the Create Hub or within a workspace. After creating an empty warehouse, you can add objects to it. Once your warehouse is created, you can create tables using T-SQL directly in the Fabric interface. Like all relational databases, Fabric's data warehouse contains tables to store your data for analytics later. Tables in a data warehouse are typically organized in a way that supports efficient and effective analysis of large amounts of data. This organization is often referred to as dimensional modeling, which involves structuring tables into fact tables and dimension tables. Fact tables contain the numerical data that you want to analyze. Fact tables typically have many rows and are their primary source for data for analysis. For example, a fact table could consist of sales transactions, log data, or sensor observations. Dimension tables contain descriptive information about the data in the fact tables. Dimension tables typically have a small number of rows and are used to provide context to the data in the fact tables. Tables for dates, products, customers, stores, and employees are common dimension tables. In most transactional databases that are used in business applications, the data is normalized to reduce duplication, and it makes sense when dealing with individual transactions. In a data warehouse, however, the dimension data is generally denormalized to better handle aggregations over large amounts of data and reduce the number of joins required to query the data. Often, a data warehouse is organized as a star schema, in which a fact table is directly related to the dimension tables. In most cases, the fact table will contain aggregations of data, which the dimension tables will then filter, allowing analysts to see only what's relevant for insights. If there are lots of levels or some information is shared by different entities, it might make sense to use a snowflake schema instead. A snowflake schema is considered a more normalized version of the star schema. In this case, the dim product table has been split up or further normalized to create separate dimension tables for product categories and suppliers. Also, a dim geography table has been added, containing information on where customers and stores are located. This is also called a bridging table, which can help dealing with dimension tables that require filtering against each other, where there may be a many-to-many relationship. Great work, detectives. We have our objects created and our data loaded into our tables. Time to report. Well, not exactly. We need to build a model for data analysts to generate reports, which brings us to the next mystery, the modeling menace. Let's look at the clues. A semantic model defines the relationships between the different tables in a model, the rules for how data is aggregated and summarized, and the calculations or measures that are used to derive insights from the data. These relationships and measures are included in the semantic model, which is then used to create reports in Power BI. All right, so we need a semantic model. Let's look at how we can do this in Fabric. You can easily switch between the data, query, and model view in Fabric using the menu at the bottom left corner of the screen. The data view shows the tables in the semantic model. The query view shows the SQL queries that are used to create the semantic model, and the model view shows the semantic model. Relationships allow you to connect tables in the semantic model. You create relationships between tables in your data warehouse using a click and drag interface in Fabric in the model view. Measures are the metrics that you want to analyze your data warehouse. Measures are calculated fields that are based on data in the tables in your data warehouse using the data analysis expression or DAX formula language. Building out the semantic model is a critical component to preparing your data for use in downstream reporting. To simplify things for your report builders, you can hide elements from view, either a table or a column. Hiding fields removes the table or column from the model view, but it will still be available for use in the semantic model. Every time a data warehouse is created, Fabric creates a default semantic model for analysts and/or business users to connect for reporting. A semantic model has metrics that are used to create reports, and semantic models are automatically kept in sync with the data warehouse, so you don't have to worry about maintaining them. You can also create custom semantic models to meet your specific needs. In Power BI, a semantic model is always required before any reports can be built. So the default semantic model enables quick reporting capabilities on top of the warehouse. The default semantic model inherits business logic from the parent warehouse, which initiates the downstream analytics experience for business intelligence and analysis. New tables in the warehouse are automatically added to the default semantic model. Users can also manually select tables or views from the warehouse they want included in the model for more flexibility. Objects that are in the default semantic model are created as a layout in the model view. For report readability purposes, it's always a good idea to rename columns to more user-friendly names, as well as hide objects that users won't need to view. Okay, Jason, we have a Fabric warehouse, properly formatted a schema, we ingested data into our tables and built a semantic model. Now can we report? Yes, we can, but reports are just the start. Let's look. Fabric enables you to visualize the results of a single query or your entire data warehouse without leaving the data warehouse experience. Exploring data while you work to ensure you have all the necessary data and transformations for your analysts is particularly useful. And yes, reports. Use the New Report button to create a new Power BI report from the contents of your entire data warehouse. This opens the Power BI service experience where you can build and save your report for use by the business. All right, detectives, that covers all the fun stuff regarding warehouses. I imagine at this point your biological data warehouse is reaching max capacity, but hang with me for our last case to solve on this topic, the security sleuth. Security is a critical aspect of managing your data warehouse. Fabric provides several security features to help you secure your data warehouse, like the ones listed here. Access, encryption, and auditing are critical for any solution in implementing. Security features like the ones listed are just as important. Data in Fabric is organized into workspaces, which are used to control access and manage the life cycle of data and services. Appropriate workspace roles are the first line of defense in securing your data warehouse. In addition to workspace roles, you can grant item permissions and access. This enables you to share a single data warehouse for downstream consumption. You can grant permissions to users via T-SQL or in the Fabric portal. You can grant the following permissions to users who need access to your data warehouse. The read permission allows the users to connect using SQL connection strings. The read data allows users to read data from any table or view within the warehouse. The read all allows users to read data from the raw Parquet files in OneLake that can be consumed by Spark. And build allows the shared recipients to create reports on top of the default semantic model that's connected to the warehouse. A user connection to the SQL Analytics endpoint will fail without at least the read permission at minimum. Granular permissions can also be set within the warehouse itself using T-SQL. Common permission settings are object, column, and row level security, as well as dynamic data masking. And always remember to use the principle of least privilege when considering access. Leverage permissions accordingly, and keep in mind that you can apply these permissions to intra-ID groups as well as individuals. Now that we covered at a high level what a Fabric data warehouse experience is, let's put knowledge to practice and deploy a warehouse in the DetectoLab 5000.
All right, back in the environment. Now we're going to create a warehouse, which really doesn't take too long in Fabric, but I want to also kind of outline the differences between the lakehouse and the warehouse as well, just to give you those nuances between the two and what the visual interface at the time of this particular demo is being presented. User interfaces change all the time, so the way things show up in Fabric may differ based on when you actually watch this and when you're applying these techniques to it. So I'm here in my workspace. Now I can create a new warehouse in several different ways. I could go into data engineering. I could even go into data warehouse here from my experiences and create a new warehouse from the data warehouse experience. I can also just go into my workspace, look at more options, and create a warehouse from here as well. And that's what I'm going to do here. Now I'm going to call this World WWI WW Importers. Or we'll just call it Worldwide Importers. Importer, Worldwide Importer. All right. And then we'll go ahead and hit create. And that's really it. I mean, this Fabric in and of itself is going to create the SQL endpoint for us to work with in this. And if you're comfortable working with, tools like, SQL Server Management Studio, something like that, then this gives you a little bit of that more warm fuzzy feeling. Yeah, it's a little watered down, isn't quite feature rich as what SSMS is, but You could see that I have my worldwide importer and I have my schemas, my security, like my roles. I can create roles. All this makes me feel good in SQL. And then my queries pane and then my shared queries. Up at the top, you can see I can refresh this. There's settings that I can look at and apply. Here's my SQL connection string. So if I need to connect to SSMS, which we'll do in another demo, we'll connect to SSMS or other third-party tools, and I have this SQL connection string, and I can use my intra ID credentials or my email credentials in order to log in with that. I can also set sensitivity labels for this. We'll just set this to all employees, right? And then endorsement, I can promote it. I can't certify it because I'm not the tenant admin, but then we can sync the default Power BI semantic model with the workspace. That's one of this is also a great part or a great feature about this data warehouse experience is that I have a default Power BI semantic model that's created with this. Now I can sync the objects. So if I create new tables, new objects, new columns, new things like that, it will sync with the default semantic model. And default semantic models are great for quick reports. It's not really great for doing a lot of customization with it. But if I wanted to do quick analytics on something, then syncing this default Power BI semantic model is going to be nice. I'm not going to do that, but I do want to show that. So those are the settings. Now I can get data through new data flows or pipelines. I can also, if I wanted to, I could send, notebook. I can work with notebooks as well and send it to the warehouse. I can create new SQL queries with this and new visual queries. We'll do that in a later demo, but this is where we can create those objects, right? And this just expands the ribbon so I can see this in full view. We could create a new warehouse if we want, right? I can look at the ones that I have. And connect to those and search for them. I can look at whatever schemas I have, security, and then whatever queries that I answer. Obviously, this is brand spanking new, so I haven't added any queries in it. But anytime you open up a new query, they automatically get saved in the queries section of this. I don't necessarily have to save this. The other thing I want to show you is the different options down here. So we have our data view, we have our query view, and we have our model view. Now, if I wanted to open up SQL Query and do a new SQL query, I could do that. Or I can go into the query blade and it'll create new SQL queries. Now, I haven't even written anything, and you can see that I already saved a SQL Query 1 in here. So I could come back, even though this is blank. I haven't saved it, so it went away. But you could see that I could do this. I also have a model tab. I can't use it right now. Why? Because I don't have any tables in here. It isn't going to create a default semantic model for me in order for me to view this, which is why some of these other reporting features aren't available to me either. Like the new report and the new measure. When I have tables in my warehouse, then these options should pop up because the default semantic model will be created at that point, and I can work with it there. Now, what's the difference between this and the lakehouse? Well, let's move back and forth. I have it right here, and I have my sample lakehouse here. So if I go into my sample lakehouse, the first real difference you're going to notice is that, up here, I don't have an option to switch from a SQL endpoint to a lakehouse, right? I have two different explorers here. I have a lakehouse explorer and a SQL Analytics endpoint. The SQL Analytics endpoint is going to reflect more of what the warehouse looks like, right? Because I have my schemas, I have my tables, I can look at the warehouses that I have created. I already have tables in here, so I have my data, my query, and my model views. So I can go through and look at all these same options, right? So it has a SQL endpoint built into it. One of the main differences is that this SQL Analytics endpoint in the Lakehouse is read-only, as opposed to the warehouse, which is read-write. So I can't write back to the warehouse. I have to go in and work with notebooks and do things like that. The SQL queries that I use for the warehouse version, I can actually modify and persist those changes into the warehouse itself. So that's a huge difference between the Lakehouse and a warehouse. But I did want to show that you have two different options. When you're in the Lakehouse Explorer, this gives me or exposes those files as well. So a warehouse is just like your typical SQL warehouse, right? We have our objects and everything that we create in there. We don't have this extra view into the one lake like we do with our lake house. So that's another huge difference, is that I also have the ability to expose any files that are stored within my one lake here in the lake house. So those are the main differences between this. But that's really all you have to do to create a warehouse, is just tell it you want one. It'll create one for you. It'll create the SQL endpoint. Easy peasy. Not much to have to work with in order to set this up. Super easy.
Great work, detectives. We solved several mysteries involving data warehouses: what they are, how to create one, the elements needed to form a semantic model for reporting, as well as some security aspects. Thanks for joining.